Now we have to add some new fields in the character component for jumping. Make a new field called base jump magnitude and a property called jump magnitude. We need to use them in the jump state. Let's get back to the editor. And don't forget to regenerate nodes after modifying the character component. We also need to add a new input action to the input action asset. Just call it jump and set C for the path of binding. Then press the Save Asset button after those changes. Now create the takeoff state and also the flight state in the state graph. Then make a transition from idle to takeoff state. After that, add an onInput System Event button node. Select Jump for the input action field. When the input system event is raised, trigger the transition. Let's see if it works or not. Great, it works fine. We need to do the same thing for the transition from the run state to takeoff state. Now we are going to implement the graph of the takeoff state. Before that, set the base jump magnitude to 6 in the character component. For the content of takeoff state, we need both character and rigid body 2D object variable for this graph. Then access the jump magnitude from the character. And we also need to add a rigid body 2D dot add force node and a create vector 2 node. Then apply jump magnitude to the y value of the create vector 2 node and connect it to the rigid body 2D dot add force node. Also change the force mode to impulse. Now have a test on the takeoff graph. It seems to be working properly. Let's move on to the next part. We need to make a grounded checker for the payload. In order to do that, we have to make some adjustment to the character component. We need to create a private field called isGrounded, and also a public property to access it from the graph. To make a grounded checker, we need to add a new layer. Now press the Layers button at the top right corner. A drop-down menu with all layers will be shown. Then click the Add Layers at the bottom. We are able to add the layer settings right here. Select User Layer 6, then input Terrain for the new layer name. Lastly, set the layer of the tile mat object to Terrain. We also need to add Contact Filter 2D and System.Array in Type options. Go to Add, Project Settings, Visual Scripting. Add both of them and click the Regenerate Nodes button. After that, let's create an empty child game object called Grounded Checker in the payload object. Then add a script machine component into that game object. We are going to implement the content of the Grounded Checker graph. Now add some object variables which are necessary for this graph. First, we need the reference of the character component, and also the collision box of the payload object. Here is the graph of the grounded checker. Let's have a quick look. We need to add two graph variables. First one is filter. Then select contact filter 2D for the type. Second one is his buffer, and leave it null for the type. This graph is divided into 3 parts. The first part is to initialize those two graph variables, filter and his buffer. We need a onStart event node, which only executes once with Visual Script get enabled, and also a sequence node. Create a new instance of Contact Filter 2D, then set layer mask, and assign it back to the graph variables filter. Also an array instance of raycast hit 2D, then set it back to the graph variables his buffer. The second part is to use 362D.CircleCast to cast a circle from the bottom of the character. It returns the number of hit colliders as a result. If the result is greater than 0, then set character.isGrounded to true. If it's not, set to false. The third part is to calculate the origin and the radius which we use in physics2d.circlecast. What we need to do is get the bounds of the collision box, then get the center point of that bounds. We also need to get the size of the collision box, then multiply it by 0.5. The x value of the result is the radius of capsule collider. Subtract y value by x value, then multiply it by vector 2 dot down. Lastly, add it to the center of the bounds. Let's have a quick test on it. We are not able to display the private variables in normal mode. We have to enable debug mode by clicking the button right here, then select debug. Great, it works fine. Now we need to make the state get back from jump to idle. So what should we do? First, make a transition from takeoff state to flight state, and check the character dot is grounded with fixed update event node. If character is grounded is false, then trigger the transition. Let's copy the whole transition graph because we are going to reuse it. Make another transition from flight state to idle state, then place the graph we copied before. Don't forget we need to make an adjustment to the branch node right here to trigger the transition if character dot is grounded is true. Okay, it's time to have a try. Great, it works fine. Let's move on. Let's talk about how to make visual scripting easier to manage. As you see, we have a number of object variables for the planar movement behavior, and also the grounded tracker. We are going to put those references into the character component instead of using object variables. We have to add 3 private fields and public properties for the reference of rigid body 2D, collision box, and planar input. Let's get back to the editor. Don't forget to regenerate nodes in project settings. Then drag the object to the corresponding fields in character component. Rigid body 2D to rigid body 2D, collision box to collision box, and so on. Now we have to make some adjustment on the planar movement behavior graph. We are going to use the public properties of the character component, which we add before to replace those object variables. Character.planar input to replace the variables planar input. Do the same thing to every part which use those object variables. Everything seems to work fine. Great. Let's move on to the next part. The planar is only able to do the vertical jump. Therefore, we have to make some changes on the graph of takeoff state. To apply horizontal force to the planar, what we need to do is get the value of move input action. We also need a not equal, a branch, and a mathf.sign node when the x value of move input action is not 0. After that, add a select on flow node to determine which value should be chosen. If we enter the node from the input port A, the output port will return the value from the input port A. Entering from B, then it returns the value from B. If the value of move input action is not null, and the x value is not equal to 0, then enter the select on flow node from input port A and use the value from mathf.sign. If it is not equal to 0, then enter from input port B and set the input value to 0. Lastly, use the output value of select on flow node to multiply with the move speed of character, then apply it to the x value of vector 2. Let us have a test on it. Great, everything seems to be working fine.